The diagrammatic representations of three-phase systems with respect to the overview of distribution network from the power station to the end user. In the diagram we can see that power is typically generated in a delta configuration in order to generate maximum amount of current flow. From there the electricity is moved to a step up transformer, which is typically a star delta configuration, which then steps up the voltage for high tension transmission lines. On the receiver side we get our first step down transformer, which typically is delta delta configuration. From there it goes to our substations, which typically has a star delta configuration, and then the transformers that we find in our urban areas are star star configurations in order to get a fourth line. From there we've got our 4 lines that then feeds into domestic applications. So each phase will have the neutral point as well as one of the lives, and then the manufacturing will have the 4 lives as well as the neutral point connected to those in order to supply the 3-phase energy required for manufacturing. We've established in the previous videos that in a star system we will have the line current and the phase current equal to each other. We will also establish that the line voltage is equal to the square root of 3 times the phase voltage. We can clearly see this configuration or this comparison when we're looking at the 3 single phases and the waveforms generated, whereby this voltage is, when comparing that phase voltage, the red one, compared to the yellow and the blue phase voltages, we can see that the sizes are larger on the phase combination than on the line. With the delta configuration we get the exact same scenario. However, my line voltage and my phase voltage are equal, and then my line current is equal to square root of 3 multiplied by my phase current, for the same reason. When it comes to power, in 3-phase systems we've got 3 types of power. First type of power is the true power, also called the active power, and we calculate that as P equals the square root of 3 multiplied by the line voltage and the phase current, the line voltage and the line current multiplied by the power factor of the circuit, or the angle between the voltage and the current. Second type is the reactive power. The reactive power is the inductive power, technically, the stored power, square root of 3 times the line voltage times the line current, but now we say sine the phase angle. The apparent power forgive my spelling. The apparent power S is equal to the square root of 3 VL IL, where VL is my line voltage and IL is my phase voltage.